scalable logging platform. Ricardo Castro, thank you very much for being here with us.
It's working? Yeah. Good afternoon, everyone. First of all, let me thank the organization for accepting my talk and congratulate you on your bravery to attend a talk about logs after lunch. So, welcome. And we'll talk a little bit about logs, although not a popular.
You're not feeling comfortable?
It was falling off. So.
Okay.
Is it good?
I think it should stay now. Okay.
Okay, so now we're doing it. So, although not a new topic, it's something that I usually find some issues, especially in startups that are growing up and grow up very fast, and they usually get into pitfalls. I've gotten into those pitfalls myself, so I thought it would be a good topic to actually explore a bit. So, this is more or less the agenda that we have for today. We'll go through some of these topics and we'll delve right into it now. So, what's a log? But generally, it's something that you deem important enough that you need to store some information about it. It can be a transaction that's done on your system. It can be a transaction on a database. It could be an event. And I've pulled out some random definitions from the internet, just a quick Google search. And you can see that more or less the process is the same. So a log is something that you need to record, and logging is the process of keeping those logs somewhere. Some logging tips before we go into the platform itself. So the first tip is know your audience. What do I mean by this? So logs are usually consumed by two separate entities, machines or human beings. So machines are very good at processing large amounts of data, but they are not good at processing unstructured data. So they're expecting a format. If something comes a little bit out of that format, they will have some trouble handling it. On the other hand, we have humans. So humans cannot process that much information as well as computers do, but we can handle some unstructured data when we get it. So know your audience. We should strive to find something in between that works for both humans and computers. This fits right into the next one, which is have a consistent structure across all your logs. So it's very easy, especially in the microservices area with different programming languages, different frameworks, everything, that to have different structures among your logs. It comes at the penalty of making debugging a lot harder. It makes harder to actually try to figure out what's going on. Maybe some stuff has the timestamps, maybe others don't. Maybe the way that the messages are written are different. So we need to strive to have consistent structure across all logs on our infrastructure. Another good tip is to avoid reporting alerts and exception handling. This is a little bit debatable. So, but the point here is that if you already know that you have an exception or you have an alert, don't just trust on your logs to actually report them. You already know that you have an exception, so just send an exception somewhere, even though you can actually log and say, this didn't work, but use something like Sentry or create a metric somewhere else, because you already know that you have an exception. It's very hard to have a huge stack trace on the middle of your logs and then go into that stack trace and that everything is mixed up. The thing that people usually mix up are log levels, so use your log levels properly. So when you're logging an error or an error, when you're logging log debug, don't just use the same log level for everything, so keep consistency. Another good tip is to always provide context. It's very different to have a log saying database failure or a log saying fetching preferences for user X failed because of database failure. So you should aim for each log message to have a clear context of what is going on, so that you can easily understand what the failure is, or if you're doing development, to understand what the hell is going on. Reaching the end, you should log as much as necessary, no more nor less. This will be, of course, highly dependent, but if you have too few log messages, you probably get into the point where those log messages are pretty useless because you can't understand anything that is going on. But if you log too much, you go into the risk that you're having so much information, so much clutter, that it becomes really hard to actually trying to find out what is going on. And last but not least, this is one of the most common mistakes that we all do, is log-sensitive information. I think in recent years they've been more careful, especially with things with GDPR and some scandals that have been in the news of credit cards being released or PII information being released. Most of the good frameworks out there already have support for some of these things, but be careful, because you can even put a log that comes from a middleware somewhere and can be stored somewhere that you don't even know, and then those get hacked and your company is liable for that. So let's start by looking into a logging platform. And the first thing that I would like to say, if you are actually fully committed to building your own platform in-house or on a cloud provider, what it is don't. And I mean this. And I'm trying to make this a little bit of a fun, a little bit funny, but the point here is that you should think very carefully before you actually build your own fully complete solution of logging platform, and mainly because of this. This is no publicity, but there are a lot of options out there. I'm just showing a few, but I could keep going. You do a search, and there'll be lots and lots of these options. Of course, these come with a cost. Some have tiers, some provide more functionalities than others. But the point here is that if you want to build a logging platform, maybe there's something out there that already does some of the heavy lifting for you guys. But if you want to go with an option, at least you have to take care of all of this. So you will need infrastructure. You will need servers to actually host your logging platform, so you have everything running. You will need services. Those servers will have services that will index your logs, they will store your logs, they will do processing of your logs. You will need to handle storage, so you need logs somewhere, so you will need to actually keep them safe somewhere. You'll need backups, you probably need redundancy. Maybe you need to store logs for 5 years for terms of compliance. You'll need to handle traffic. So if you're building your platform yourself, probably most likely you're using a cloud provider, you will need to ingest logs, and those come with a penalty of traffic, and that will have a cost. Of course, everything that is mentioned here needs maintenance, so we will need to do upgrades. Things will fail, servers will fail, so this will need updates. So maybe you want to upgrade to the new version of your indexing solution, and it has something that's breaking, so this will need to be updated. You'll need debug. Something will stop working. Someone is sending logs and they're not showing up, so we'll need to actually figure all of this out. And of course, it's infrastructure like anything else. You'll need to monitor it. You need it when it's up, when disks are getting full. You need to handle all of this. And this comes at the cost of human resources. So most likely, you will get into the point where you will need to decide if you do it everything yourself or if you offload this to someone else. Most likely you'll be somewhere in between. So even if we want to go about this, what do we need? So we will need a scalable logging platform. What do I mean by this? So as soon as your infrastructure starts to grow, you will produce more logs. So you will need to handle that capacity. If you have something with automatic scaling, you can get into the point where you're having dozens or hundreds of servers, and then all of a sudden you have hundreds and terabytes of logs that you need to handle. It needs to be close to real time. It doesn't have to be exactly real time, but it needs to be on point. So if you're debugging an issue, you don't want an issue to happen in the morning and you only see it at the end of the day. So you need to be able to fetch the information as close as possible as things happen. It needs to be inexpensive, and here I have double quotes, inexpensive in the sense that if we are spending too much money, and that can be either on solutions or in human resources, maybe we can offload some of that cost to someone that actually manages that for us and actually build our product ourselves. Unless you are building a solution for a logging platform that you are selling, maybe this is a point where you need to make that decision. One key aspect of this, it needs to be flexible and pluggable. The talk is called building, so the idea is that you build and add resources as you need, so you will need to put things in, take things out, and then those things need to work interchangeably, and they need to speak to themselves. Try to choose some tools that have a large user community, so if you try to build it yourself, you'll be only responsible for the things on your own. So try to choose tools that are highly used in the community and that you can reach out to people and ask for help. Use standards. We are all engineers, we all like to build stuff, but we'll get into the point if we build everything in-house, we'll be the only ones responsible for maintaining those things, and we'll have some troubles along the way. And if possible, use open source so you can have some control over it. You can do PRs, you can extend yourselves, you can ask the community, you can ask the maintainers if they can do something to help you. So that would be a nice option. So what does this look like in terms of components that we'll need for this platform? So these are probably the 6 biggest components. We'll touch briefly on each and every one of them. So collection. So the collection is the part where we actually get the logs. So there will have to be some tool or some process that knows where the logs are and gets them so that they can be shipped somewhere. Next, we need to ship them. So we need something that transports logs from point A to point B. What that is, we'll see in a bit in our context. But we'll need something that actually grabs the logs from the collected part and push them to somewhere. Next, that transport will deliver those logs to some place that they will need to be indexing. Here, indexing can be some sort of processing and then shipped somewhere else, or it can be actually that somewhere that the logs sit that they can be visualized. Of course, all that comes with storage. So we are indexing, we want to keep logs. We may need storage long-term, short-term. That will depend on each one of our needs, but we need to actually have somewhere to store the logs for X amount of time. Logs need to be analyzed, so most likely we are looking at logs because something failed. We need to understand what's happening on our system. Maybe we are developing, this is a development environment, and we need to see what the hell the applications are doing. This could be analyzed by a security team to trying to find some pattern or someone that is trying to go into our systems. It can be a lot of things. And at the end, we may need to build some alerting. Something happens on your logs, you may want to alert, send a message, send an email, send a page, whatever it is. What does it look like generically in terms of architecture? So here we have hosts. I make here a distinction between using a shipper or not. So a shipper will be a tool that is actually getting logs from somewhere and sending them to an indexer. And at this point, and in here I didn't put the shipper just to show up that the applications can send the logs directly. So here is the collection part. So both hosts and the services that are running there that come built in are shipping logs to an indexer, or applications can send. So the indexer will be the component that will be responsible for basically getting the logs and making decisions where to send them, maybe do some processing, adding information, retrieving information, sending the stuff everywhere. There's a solution for long-term storage. So usually long-term storage will be used mostly to back up information, maybe because of terms of compliance or whatever the needs are. But it's usually logs that should not be ready for immediate consumption. Then we'll have some part of the infrastructure we actually store and analyze. So this is mostly will be some user interface that you can search for logs and search for applications, separate by environment or whatever they are, and probably some alerting just saying this happened, you need to look into this. So how do we go about this with tools? So just to give you some context why we were planning on doing this. I work for a company called Venium. We have mostly two engineering teams, a team that works directly in an embedded, so software that runs in vehicles, for example, and the team where I work, which is the cloud. And although the company did a pivot a couple of years ago, and we started to build new services, new infrastructure, and we got to a point where we decided, okay, so we really need a logging platform, because not only for us, but because we have strict requirements from clients, and we need to handle this. So these numbers are a little bit outdated, but this is the slide that I could get from the company. So next, so does anyone want to try and guess the point where we were when we started to develop this? Any guess? The logging platform that we had at the moment, at that point in time. Sorry? This is it. And I can say that for the most part, this was enough, and I'll say you why. So, like I said, the company did a pivot, and we had a lot of proof of concepts with prospect clients. If you worked or has ever worked in the automotive industry, you know that it takes a long time to have everything, since you develop code to actually have it shipped, it can take years, and you can even be in the process of, for I don't know, 2 or 3 years, and not having anything deployed. So some of those are proof of concepts. They can be paid or not, but there's a lot of process going on from the beginning of the project to the end of the project. What this means is that you want to invest them as much as possible in actually integrating with your customers and trying to having stuff out, but you only want to really invest and having stuff out when you need it. So for the most part, this was mostly enough for us. At this point, both services running in hosts and applications logged to our syslog. We had disks on top of this with some redundancy, and most of these projects were like proof of concepts and integrations that would be there for, they were time boxed, and they will be there for, I don't know, a few months, and then maybe we need to rebuild something. So there was no real need to actually have something more than this. But then things started to go well, and we needed a little bit more. So where did we grow from here? So this was our first dab at trying to build a logging platform. So we started by having applications logging directly to something called FluentD. We had everything in servers, more or less static infrastructure, but everything already with containers. Everything was deployed with Puppet, and we just redirected Docker logs to go to FluentD. We'll see what everything of these components are. So FluentD would be responsible for getting those logs, and with some configuration, they would process the logs and send them to 2 parts. The top part is our long-term storage, which is S3 buckets. So we're mostly hosted on Amazon. So S3 buckets was a nice option for us to store long-term. And then we used Graylog and Elasticsearch underneath to have the indexing and analyzing part. So FluentD is an open source data collector. It's hosted by CNCF. If you're hosting your infrastructure on Kubernetes, it has awesome support for that. So we are migrating, or most of our new systems are already in Kubernetes, so it was an excellent candidate. It's open source, and you can easily deploy, and it has a lot of integration, especially with Kubernetes, to actually make it work. Elasticsearch, we already had some projects that were using Elasticsearch, so we could just leverage what we already had in-house to actually store the logs. Graylog, it had a big plethora of things that we thought we could need in the future. Some of us already had experiences from previous companies working with Graylog, so it seemed like a good option to have a user interface for searching for logs. And it had the added benefit that Graylog actually manages the Elasticsearch indexes, so we don't need to actually take care of it. So we just send to Graylog. Graylog can buffer, and it does all the managing of the Elasticsearch indexes for us, so it would seem like a nice option. And of course, Amazon S3, we use it for long-term storage and for data teams to go in there and fetch information whenever they want. So this seemed nice for us at the moment, but we wanted to see where we could go from here. So we started to do some experiments, and we got to something like this. Of course, we didn't invent nothing like this. We didn't want to reinvent a wheel, so we started to see what other companies were doing. And we got into the more or less of this architecture that we felt after some experiments that we could actually handle loads and loads and loads of logs if necessary. So here we have a few new components. So near the hosts and the applications, we have a shipper. This looks like FluentD, and it almost is. It's called FluentBit. It's like a streamed-down version of FluentD. All those logs would go to Kafka. Then we would have FluentD consumers that would process those logs and send them somewhere else. So these FluentD consumers could be all doing the same thing, or they could be separated. One could be sending to long-term storage. The other one could be sending to Elasticsearch. Then could be sent to some external application that we needed. At the time, we were thinking about using Splunk for some integrations. So Elasticsearch, we were planning on doing a shift because we're hosting on AWS, and if we use their managed service, this would come freely. So we thought it would be a good way to do such try. And then, of course, we can trigger alerts. So what tools do we have here? So FluentBit. It's an open source log processor. It's a streamed down version of FluentD. Uses a lot less resources, but it had all the integrations that we wanted. So it looked nice. Next, Kafka. We already were using Kafka inside, so if you use Kafka, you know that it scales immensely, so it can go almost to infinity, so to speak. But it will handle a lot of logs and will do buffering for us. It will do backpress, so it would be perfect for us to have Kafka already. Again, Kibana, we were using AWS. It came freely, so it would be a nice addition to our infrastructure. Of course, chat service, email service, pages service, whatever tools that you're already using, both Fluentd, Kibana, they almost support. And then we started to use Glacier. For those of you who are not on AWS, just to give you some context, so Amazon S3 has the normal buckets. It has Glacier and also has Deep Archive, which we are not using at the moment. So the difference between a normal S3 and Glacier is that Glacier is a lot less expensive, but comes at the cost of being a lot more expensive to get stuff out. So we're using mostly Glacier to store logs that we most likely won't need them, but we are under compliance and we need to store them. So we're basically storing logs with more than 1 year or 2 years, depending on use case. So we weren't at this point yet. We just did some experiments. This looked good. So what did we go into? So this is our next step. So at this point, we started to migrate everything to Kubernetes. New applications were already there, so this is what we got. So we had shippers on the hosts getting logs from services that were running there. Applications would log normally, and then we'll have Fluentd just getting those logs and shipping them somewhere. All those logs would end up in Kafka, and then we would have Fluentd processes that will send them to the outputs. Again, S3 on Amazon, you can configure objects to go from S3, normal S3 to Glacier automatically after a period. So we did that configuration, and then we're sending logs from Fluentd to Elasticsearch, and then we have Kibana on top. So this is as all the stuff like having the environment appended, we have a bunch of information here. The only caveat that because we removed Greylog from the equation here is that we have something to actually manage the Elasticsearch indexes, so we don't want information with more than X amount of time here, so we just delete them. But we had here a component that after a while, we found out that we actually didn't need, so we went to a more streamlined version. So we've proven that we could actually use this, but, we actually didn't need it. So the issue here was that both FluentBeat and both Fluentd already have some capabilities in terms of buffering and backpress and all that kind of stuff. And for our needs, it was actually more than enough. So we decided to remove Kafka out, and we use directly FluentBeat and Fluentd communicating directly. Everything, the rest looks exactly the same as it looked before. But because these tools speak with each other and have integrations with everything, it was very, very easy to actually just pop something out and put things communicating directly. We did this decision, and now we're thinking about going back, because now we have our data team that wants to get access to those logs as soon as they come. So we're probably going to switch back into this infrastructure. And that's mostly it from my part. I don't know if anyone has any questions. Go back.
You talk about the FreeND and Elasticsearch.
Yep.
But in the stack of Elasticsearch, you have brand agents such as beats.
Sorry?
In Elasticsearch,
yep,
you have some beats,
yep,
like metric beats, file beats,
yep,
audit beats, and so on.
Mm-hmm.
So why do you use the FreeND?
So our decision, mostly some of our teammates already used Fluentd. I had used it in the past. We were thinking about going with whatever CNCF was using. So Fluentd, if you're going with Kubernetes, is more or less, let's say, the standard of actually deploying. It deploys very easily within a Kubernetes cluster. It seemed like the good solution for us. It had all the integrations that we needed at that point, even stuff like that we are thinking about using like Splunk. It's supported out of the box. It had both FluentD and FluentBeat, so it looked nice for us. So we're, like I said, we were using Amazon Elasticsearch provided service, so we were just using this as a service. So FluentD worked wonderful for us. No reason in particular, not saying this one is better than the other.
Thanks for the presentation, Sami from the United Nations. You have mentioned in the next slide that you take out Kafka and then you get it back. Could you please explain why the reason that you get it back?
Yep.
Since it's a streaming platform,
yep.
How it can help you in getting these logs working?
Yep.
Thanks.
So we tried Kafka because we wanted to see if it worked well or not. So it worked well, but we didn't need it. So the issues, we didn't have any issue, but we were managing a Kafka cluster only for logs. We're not reusing any Kafka cluster that we already had, and we could live at that point in time with only FluentB and FluentD capabilities. So mostly we were using Kafka to buffer messages where no one was pinging on them. So we decided to take it out. So both FluentD and FluentBeat and FluentD can buffer and can do back pressure. So that was more than enough for our needs. We're thinking about going back because now we have a data team that actually wants those messages earlier than they get to an Elasticsearch or to an S3 bucket. So we just we'll plug it in and let them read into those messages.
Any other question?
Up there. Up there.
Thanks for the great talk.
Thank you.
I just wanted to ask at what point do you do filtering? Is it your second instance of FluentD?
Yeah.
Okay.
So mostly we're doing most of the filtering here. So FluentBeat only has configured, go get this log or go into this log or do whatever you want to and push it either to Kafka or FluentD directly. And then FluentD, we have more than one instance, has a configuration file that can be as simple as forward the same log to S3 and Elasticsearch or add information, do some processing, and we're doing mostly here. Then on Elasticsearch, we're having all filters by environment, timestamps, and all that kind of stuff.
Okay, and the input log is already structured? It's already JSON or something?
Yeah. So you're using to transport the messages, we're using syslog format. All our logs are JSON. So one of the work that was done even before we got here was to go into our logging framework. So we're mostly doing Node.js and Go applications, and we uniformize, make uniform all the logs, and everything was in JSON with everything with the same format. So when we reached this point, everything was working more or less the same way.
Okay, thanks a lot.
Hello. You mentioned a couple of years of retention in the
Yep.
cold storage. How did you solve the binding between the version of the software that generates the log and the log itself?
How do we fix the?
The binding,
Mm-hmm.
the relationship between the version of the software
Yeah.
in the application and the log, because after a couple of years, if you have to get back to the one that generated.
So it has a label on it. All the logs come with the release. So we work the way that we work. We don't deploy. Let me take a step back. Like I said, we have an embedded part and a cloud part. When we get stuff to customers, we do a company release. Although we have dozens of microservices that each and everyone has their own version of the application, we have a major release that we deploy to customers, and everything comes bundled. And every log comes with that release attached, basically. Sorry.
What's the amount of log you're dealing with in this platform?
So this is highly dependent on if it is something that's already in production or we are in proof of concept. So it can be easy to think that we already have in production, have a lot of logs, but every once in a while we have projects that are short-lived, or for at least for a few months, that are generating gigabytes and gigabytes, even terabytes of information, because maybe we have some integration that we actually need a lot of logs. So we're talking about a few hundred gigs to a few terabytes of logs.
And this is per year or per month?
This is mostly, I would say, gigs each month. So in a quarter, maybe a few terabytes of logs.
Thank you.
Yeah. Sorry, here.
Have you guys played around with machine learning in Elasticsearch and Kibana to like spot problems before they happen?
So we actually haven't, our team didn't do it. So one of the things that the data team, is that's mostly why we are mostly getting back Kafka back, is that the data team wants to plug into this stuff as soon as possible, and then they will plug into Kibana and S3. But yeah, there's integration for that. And one of the examples that we have here with using Splunk is because our IT team wanted to use something called a SIEM to actually do some threat detection, and that's one of the use cases that we had fluently, because already had support. We just needed to ship logs elsewhere.
Thank you.
Yeah.
Again,
Hey, no worries.
you mentioned those are applications running on devices, on machinery.
No. This is only for the cloud part. Only for the cloud part.
only for cloud.
Only for cloud. Only for cloud. The embedded team does their own thing. One of the issues is that, for instance, we run software on cars that are going to run on cars. We can't simply get those logs out. So if you have a car, you've probably gone into the shop and say, okay, my car is doing something strange, and they plug a cable in and see the logs, what's happening. So you can't just ship the logs out of the car, both in terms of compliance and also in terms of costs. So that's one of the value propositions of the company that I work with. So it's very costly for a car manufacturer to actually get stuff out of the car. I can tell you that one of the major brands actually stores up to 3 years of data inside the car, because they have no way or cheap way to get that information back. But this is only for the cloud part.
Because among the best practices you mentioned at the beginning, you said to exploit log levels.
Yeah.
So what do you do on cars? You keep everything at verbose? Because how can you change it dynamically? Oh, now it's bad.
Sorry.
What do
can
you do?
repeat?
You keep the level on the cars at verbose, so you have everything, because otherwise you have to change it dynamically somehow.
Yeah, so
to
the way
move
that
from
it's-
info to
yeah.
debug.
The way that actually the applications in the cars configure themselves is by using the cloud. So operators can configure stuff in the cloud, and then the car actually pulls that configuration and say, okay, it can be a log level. But like I said, we can't. The manufacturers won't actually let those logs be out. So it's different. It's two different engineering teams at this point.
How do you manage the security of your log? Does anyone has the access to see your Kibana, or developers and ops have different access?
Yeah. So initially, I think this died, or no. So initially, one of the options why we used Greylog was because of that. Greylog had awesome support for that. Now we're just using Kibana and using our Airback on AWS, but that's mostly how we're using. So we're kind of having a lot of care to actually not store sensitive information. But yeah, this is mostly our team that logs into logs to see what the hell is going on. We try not to use sensitive information. We have Airback, and when the IT team asks us to send something to Splunk or their own Elasticsearch or whatever their solution is, we only send the information that they actually require, and it's validated by them before actually sending it.
A few more questions. We still have some time.
Yeah.
A lot of time, actually.
Yeah.
So you can
Hello
begin.
again. One more question, follow-up
sure.
question. You mentioned that you chose Kafka as a messaging system because it's compatible with Fluent Beat, or what else? Why you choosing Kafka as messaging system rather than ActiveMQ or RabbitMQ or whatever?
The main driver was we already using Kafka, so we knew it. So we had some experience. So it didn't make sense to us to actually put another component into the infrastructure that we didn't have any experience. So that was the main driver. Another one was highly influenced by LinkedIn's infrastructure. So if you know how they manage things, so everything that produces some kind of event or log, or whatever that is, it goes into Kafka. And we are trying to follow that approach because we have a data team that basically wants access to every information that we produce, be it logs or whatever it is. So those were mostly the two main reasons why we went with Kafka. We already were using it and we didn't want to bring anything that we didn't know, and we actually managed something else. Also, Kafka on AWS or other cloud providers, they already have a hosted solution, so we could leverage that if we wanted to. We're not at the moment, but we could. So one of the requirements that we have is that working with clients, sometimes we have strict requirements to use a certain cloud provider. So if we have something that it can easily shift between Azure, Google, AWS, or whatever it is, it would be actually nice for us.
Thank you. You mentioned for the logs that was all in JSON format, but let's just imagine you have a lot of different format of logs. Which step could you add to aggregate the log with the correct format, unified format, to put them to Elasticsearch and Kibana?
So Fluentd would actually handle that. You can do processing, and if you want to, you can extend. So Fluentd works with plugins, so that's how they actually support a lot of stuff. So at the extreme, you could easily write your own plugin and put it here. So if you have something proprietary or that you really want to, and it doesn't exist, or only your company builds, you can actually run your open source Fluentd and attach your own plugin, which is I think you can develop in more than one language, but Fluentd is built in Ruby. But in the extreme, you could actually put it here and just have a configuration file that is, okay, so this log is being processed by this plugin, and it will be outputted to somewhere else.
Thank you.
Okay.
We still have time, so we can still dig in a little more,
sure,
if you want.
Yeah.
Yes.
Thank you for the presentation.
Thank you.
Kafka, you have inside your cluster, Kubernetes cluster, yeah. And you have a cluster of Kafka or just one container?
So
one pod.
For this experiment that we had here, we had a Kafka cluster just for this, but we have others. But at this point, we actually had two. We played around with using AWS managed service. So we had both a Kafka cluster managed by us and a Kafka cluster managed by AWS, and we could work with both. So.
Okay, it worked fine for you?
It worked for us, it worked fine. Okay. So we're basically using syslog format to actually send messages from one point to the other. That's why it was also very easy to take Kafka out and put it back in. So the format is the same. They both speak output our syslog 5424 and in the same thing. We just put there the messages, stick in or out. It just worked flawlessly.
Okay, thank you.
Fred?
At the beginning of the presentation, you said that you don't want to use the log mechanism for alerts and exception. What did you implement for alerts and exception?
So, like I said, this might be a little bit contentious. So the point that I was trying to do here is not sending something to a log and then process the log and then generate an alert. It's to actually, if you already know that you have an alert, do that even though if you put something in the log saying this didn't work. So something that we are using is, for instance, Sentry, that we are like producing an error message, goes there, and then we have that integrated to, for instance, PagerDuty or something, and say, okay, this application is starting to error, just do something. Although we should still put in the log saying this application is failing. So this is some kind of approach that you can have. So at the time that you know that you already have an exception or you want to trigger an alert, trigger it immediately. Maybe you have some problem in your pipeline, maybe it's taking too while, you don't want to wait a few minutes before an application starts spinning and actually being the report. So this is the point I was trying to make. Although I think there's some value actually being in the logs, because maybe you have some after processing and say, okay, so this was the point that it failed, and you don't want to correlate between platforms, but as soon as you have an alert, just send it out. Here, sorry.
Hello. I don't know all the tools you're using, but I would like to know where do you store all the logs?
So
In Kafka, you can also store.
No, we're using S3.
Kafka is just for buffering.
Buffering and
it could
storing.
be used for storing also.
It can be used, but it works more or less. It started as a message queue, so the idea is that you get information there so that someone consumes it. It's very durable. You can have information here for a long time, but it's not suitable to actually be long-term storage. That's why we use S3 buckets. Other cloud providers have the solutions that work in the same way, but mostly we're keeping our logs and long-term storage here. So everything that goes into any other part of the infrastructure also goes here.
And is it stored also in Elasticsearch?
So yeah, so Elasticsearch has the last, I think it's 90 days of logs. So you can see, so they are readily available and searchable. And then everything goes here, and after a period, I don't know if it's 3 or 6 months, we actually archive them. No, it's more. It's 6 months to a year, we archive them in Glacier.
Mm.
And yeah, we still have some time, so let's continue the conversation if anyone wants. We have this opportunity right now to exchange and share. No? We still have about 10 minutes. Yes, there's one question there, Fred.
Do you have to track transaction between different applications?
So
And if yes, do you have a mechanism to do that?
So yeah, so we will have that in the very shortly. We don't have at the moment, but we will have very shortly. But for that, we'll mostly be using tracing. We'll be using a standard, also open tracing, and use something like Jaeger to actually see those things. And of course, those will have IDs that will be present in the logs, so we can both use open tracing directly, but we could also track it within the log. So we'll have both mechanisms. But it's a lot easier to actually have something visually with something like open tracing to see, okay, this request came here and passed for all these services, and it took X amount of time on each of them, and then it came back. So yeah, but we'll not be using logs directly for that. Sorry. Yep.
It's not really on the logging part, but do you manage everything like the Elasticsearch, the Kafka on-premise, or do you use just AWS or GKE?
So we started managing everything ourselves. So we have some Kafka clusters that we manage ourselves. For some projects or for some integrations that they're not critical in terms of we don't have to have them tight control over that. So we have some instances where we have Elasticsearch, AWS solution, or Azure, or whatever the system is, or Kibana or Kafka. One of the reasons for going with Kibana was that a lot of projects we could live by using something that it's managed by AWS. We didn't have no exoteric plugins on Elasticsearch that we needed, so we could just simply use a managed solution.
So do you have a team to manage everything, or how long does it take? Do you have any
so-
idea? So you spend 1 day a month, or maybe, I don't know, just upgrading your cluster and stuff?
Okay, so from project, my team does most all of our work. So we try to follow the DevOps methodology. So we have infrastructure people, backend, front end. So we're multidisciplinary. So we manage it all ourselves. We have everything in code. We try to push everything to Kubernetes as we can. If we find that we have a managed service at this point, if we find that we have a managed service that is cost effective for what we do, we just go with it. If we don't need anything esoteric for Elasticsearch, so some plugin that AWS doesn't support, we just go with it. So the cost, like I said in the beginning, the cost of actually managing ourselves or pushing it to someone else, at this point for us, it's easier to just have it and pay the price that they're having engineers full time to just managing it.
Okay, thank you.
We still have some time, otherwise.
Still have a few minutes.
Yeah. If there are no more questions for Ricardo, anyone anymore? Okay, so let's thank Ricardo very much. Thank you very much for being here, Ricardo. It's great having you over.
Thank you so much. Thank you.